Okay, so we're working with circles, and we know every circle has a radius, and as you guys know, if this was the radius, then we would have another distance related to that, which is the diameter, which is two of the radii put together. And it doesn't matter how we measure it, and so the relationship is pretty straightforward. The circumference, which is the distance around in black, okay, is equal to pi, which is that famous number that we were talking about a little bit, and then times the diameter. Okay. And I color-coded it here so we could kind of make sure and track that out a little bit. So if I knew the diameter, I would just multiply it by 3.14159 and then get our circumference. If I know the circumference, then I'd have to just do a little bit of algebra to get the solve for diameter. Okay. One other way to represent this would be to say the circumference is going to be 2 times the radius with the pi multiplied in there. So that's because the diameter is the same thing as 2 of these, so the formula has to have that in there. So that's the basics for what you're going to do a lot of problems with. So we want to make sure you remember the definition, the circumference. If you just break down the root of the word, it ends up just being the distance around, or distance around the circle. So if I wanted to know how much ink I'm putting on right here, okay, in terms of some distance, I would want to measure the diameter, okay, and so that could be here. I'd want to make sure it went through the center, and then that circumference would be pi times that. Another way of thinking about diameter, though, of thinking about circumference, is the idea is how much does something, if it was a circular object, how much does it roll for one rotation? So if we can get it close in here, can you bring around to the front? Okay, so here's a round object. You can kind of see where it's at there, and I'm going to try to mark that. Do you see I put a little black mark right there so we can kind of keep track of how far it goes? So I put a mark here, and then I'm rotating. Oops, I'm rotating. And so that distance right there, okay, going from here to here, was the distance that it took for this to rotate all the way around one time. It's another good way of thinking about the circumference. So we could say it's the distance of one rotation of a circular object. Okay, that's going to be important, especially for the second part of this assignment, the 6.6 part. Okay, make sure they see that. Okay, let me pause. Okay, so from that first section, 6.5, we saw the relationship between the circumference and the diameter. If you knew the radius, you could figure out what the diameter was and figure it out. Or if you knew the circumference, you could solve going back and forth. And we saw that the circumference can be thought of as the distance around the circle one time, or the distance an object would roll if it was round. And this is going to be important for the second part, this 6.6 section. Some of the problems in that section involve the speed of something. Okay, and so if we know this is a distance, right? It's the distance that it might go per one revolution or one turn. Okay, so we have that as some kind of fixed thing. That if we know that let's say it went 20 meters in a certain amount of time, we could actually figure out a few things. So we're going to see in this section, in addition to finding these distances, we're going to have something that's going to say find the speed. And we use v because that's velocity, which is a concept related to speed. And that's going to be the distance divided by the time. So in the case where I had this thing right here, if it turned out that I was able to roll this, let's say 100 centimeters, and it took, so that was after it rolled a certain amount of time. Let's say we measured the time, and it was 60 seconds. Okay, we could divide that out to find its speed. So what in the problems you're going to see in this section, sometimes you're just going to find some distances for different types of objects that it can do in one revolution, but maybe it'll tell you some combination of it went 1,000 revolutions or went around 1,000 times, so that would give you a bigger distance. Maybe if you knew the time, you could find out the speed of that rotation. And that's pretty much, it's called Around the World because it has some nice word problems with it, but that's some of the basics you're going to need for that. Okay, so if you haven't already, make sure you did take some notes from this video. Be ready that when you come to class that you have those notes. I'll probably stamp them or give you some points for them, but be ready that we can actually practice some of the problems either with your groups or on your own. So thank you for watching, and thank you to Katrina, my daughter, for doing the videoing. Have a good day.